All right, a few housekeeping items for you. First of all, Oren is going around handing back your 2.5 analysis worksheet. There's about 3 or 4 of you that we never got one of those from. So you might have a 0 in your grade book for that right now. So if you didn't hand that in, and you have a 0 in your grade book, you should talk to Oren about that and make sure you get it to him. Now, this was an 18-point assignment, and most of you did really well, right around 18, 17, something like that. Some of you got higher than 18 because you were able to do the bonus. Some of you got 3 bonus points. Some of you got 6 bonus points. Some of you are going to realize that your overall grade right now is over 100%, which is great. If you got less than 18, or you want to make a stab at the bonus, even if you got 18 out of 18, remember that I'm going to give you an opportunity to redo this. So if you go into your Blackboard Grade Center and you look at, it's called 2.5 Analysis Worksheet, I think is what it's called, you can actually view the rubric. And you can see, like if you missed a point, for example, either myself or Oren might have written in there like you did some arithmetic wrong. You missed a negative sign. You added 2 plus 2 and you got 5, something like that. So there might have been a small mistake in there that caused you to not get your full points. But again, you have an opportunity to earn those points. So if you want to resubmit this worksheet for a higher grade, bring it back with you on Friday and we can look over it again and potentially give you any additional points. Any questions on that? Okay, the same thing is going to be true with your spreadsheet that was due today, right? Oren and I will look at them between now and Friday, and we will give you a score on that in Blackboard. And if you do not like the score that you got, you have an opportunity to look at the feedback that we gave you, and you can resubmit. Now, what I mean by resubmit, though, is it's saved in your shared folder right now, right? So if I go in your shared folder and I look at it and I give you a grade, I'm not going to just go back into your shared folder on Thursday and Friday and Saturday and click refresh and just keep seeing if you redid it, right? You got to let me know, hey, I made some changes, just email me. I made some changes to my spreadsheet. Could you please look at it and update my grade? Does that make sense? Okay. So that was due today, so you should have that in your folder right now, in your shared folder. What I want to do today is quickly discuss the 2.6 examples or checkpoints that I call them that you were working on last time. And I'm going to pull up the solutions, which I posted on Blackboard, 2.6 checkpoint solutions. Is there any specific one that anybody wants to talk about? Something that doesn't make sense? Anything questions-wise from that guy? Just spotting a few of them. On number 3, when you solve, you might get both 6 and 1. However, does everybody understand why 6 is the only solution? Not 1. What happens when you plug 1 back in? It doesn't work. So why in the world did I get an answer of both 6 and 1 when I did my solving? We talked about that the other day. It's what we call an extraneous solution. We created a solution that wasn't really a solution. Back when I put an asterisk beside it, back when we squared both sides. I like to put an asterisk beside that to remind myself, hey, I'm squaring both sides. I could be creating an extraneous solution. And sure enough, that's what happened when I did that. So that one, 6 is the only solution, not 6 and 1. A couple of these just required you to square both sides twice. One of these had 2 answers for checkpoint 5. Or I'm sorry, yep, one of them had 2 and 1. This one only has 1 answer because the numerator is odd. But this one has 2 answers because the numerator is even. We talked about that on Monday. And then I specifically want to touch on the checkpoint 8 right here. Some students will struggle with this concept of absolute value, and I shared this with you a while back. If we can think of absolute value as the distance away from zero, you should always know that the absolute value is going to have two different scenarios. There's the positive scenario and the negative scenario. If you think of a number line and the number 0 being right in the middle, every number on the number line has a pair, a partner, right? An opposite. 17 is opposite negative 17. A million is opposite negative million. So there's always two partners that go together, except 0 has no partner, right? So we're going to explore some of that today. So that's why we get two answers here. 3 works, but negative 2 also works because one of them results in a positive 5 and the other one results in a negative 5. And we know that the absolute value of positive 5 and the absolute value of negative 5 are both 5. That's why there's two answers. Same thing here. You should have got two answers for this guy. So what we're going to do today is we're going to talk about inequalities. So I'm going to close off this 2.6 if everybody's comfortable with that. Underneath Blackboard, you'll see some stuff on 2.7. That's the last section we're going to cover here, and then you guys know that we're going to take a Chapter 2 test on Friday, and I'll talk more about the test right at the end of class here. So the first thing I want to show you about inequalities is what we call interval notation. And give my computer a minute to breathe here. Maybe. Okay. Here's the thing with inequalities. Everything we've done thus far has been equations. Something equals something, right? We've been using an equal sign. Well, when we say inequality, we're saying not equal to. So two numbers could equal each other, or two numbers could not be equal to each other. That's what inequality means, right? So if they're not equal to each other, then one is either greater than it or less than it, right? So we use greater than and less than signs. And you guys have seen this in elementary school and junior high school. So, but you may never have seen what we call interval notation. There's multiple ways to write down the same answer. For example, this looks like the point 3, 8, like if you're graphing it, x, y. But it's also used in interval notation to express a range of answers. So when we do an inequality, we're going to get many, many answers, an infinite number of answers. Well, we can't write down an infinite number of answers. So we have to have some kind of notation that tells us what this means. So if we write 3, 8, what we're saying is every single number from 3 to 8. And when we use a parentheses, we call that an open interval, meaning we don't want 3 and we don't want 8. We just want every number in between. So it would not start at 3. 3 is not an answer. But 3.0000000000001, that would be an answer. Does that make sense? And then we're going to take every number on the number line, and there's an infinite number of them, all the way up to 8, but not including 8. So my last answer would be 7.99999999999 repeating, right? That's an open interval. Parentheses. So the difference between a parentheses and a bracket is a bracket means we're actually going to include that number. Okay? So the difference between the first two bullets here is this one still starts at 3.000000001. They start at the same place. But the second one is going to go past 7.99999. We're going to go all the way to 8, and we're going to include 8. Here you can see on the third one we would include 3 but not 8. And on the fourth one we would include both 3 and 8. So bracket means include me. Parentheses means go really close to me but never quite get to me, if that makes sense. And I'm sure some of you have seen that before. Sometimes in interval notation we don't use parentheses and brackets. Sometimes we use closed dots and open dots if we're looking at a number line. A closed dot is the same as a bracket. An open dot is the same as a parentheses. Or sometimes on a number line, we'll actually use the parentheses and the bracket on a number line. So all of this is just notation. This is how we write our answer in interval notation. And we'll get some practice doing some of this. So before I have you try a few practice exercises in inequalities, I want to share one thing with you, and that is, give me a second here. Okay, what we're doing here is we are solving inequalities. So, for example, earlier on we were doing how about 2x plus 3 equals 10. That's an equation because we used an equal sign, right? So we would solve that and our answer would be x equals something. Well, now we're going to do something like 2x plus 3, not that it's equal to 10, maybe it's greater than 10. Or maybe it's less than 10. Or maybe it's greater than or equal to 10. Or less than or equal to 10. We'll have one of those signs. But as far as the procedures that we go for solving these guys, if we're doing them by hand, nothing changes. We can still add, subtract, multiply, and divide from both sides of the equation. We can move things around. We're still going to solve for x. The only difference is we're not going to say x equals in the end. We're going to say x and then one of these signs, right? Now there is one tiny little difference here. For example, if I had, 2x equals negative 6, and I wanted to solve, let me try this one. What happens if I had negative 2x equals 6, and I wanted to solve that guy? I would just go divide by negative 2, divide by negative 2, x equals negative 3. You guys comfortable with that? What happens if I had negative 2x is greater than 6? Yeah, I'm gonna still divide by negative 2 to solve, correct? Yeah, and most of you already know that when I do this, the negative 2's will cancel, so I get x over here, and over here I get negative 3, but some of you have already done this, and some of you are kind of flashing this. We have to flip the inequality sign. You guys familiar with that? Yeah, so my answer is not x is greater than negative 3. It's actually less than negative 3. Now, I expected most of you to know that, and I bet most of you have memorized that. You learned that in junior high, and you've just always kind of known that. I also would suspect that some of you have no idea why we do that. You just do it because you memorized it. Okay? I'm all about you understanding things, not memorizing steps. Okay? So I want to just give you a little scenario here. What if I told you, get a new piece of paper here. What if I told you that x was greater than 4? That'll be my fact. X is greater than 4. I want you to take a look at that on a number line. Let's say that's 0. Let's say that's 4. Let's say that's negative 4. If x is greater than 4, can you guys visualize on the number line where x would live? It would be somewhere to the right of 4. Do you guys agree? If you're greater than something, you're to the right of it on the number line. So x, I'm just going to arbitrarily pick a spot for x. Do you guys agree that x could live right there? That's greater than 4, is it not? Okay, so what happens then if I took my inequality and I decided to take both sides times negative 1? If I take both sides times negative 1. Well, now I have negative x, and over here I have negative 4. And I'm not going to write in my inequality sign yet. It was originally greater than. Okay? Well, now I have a negative x. So if x lives right here, positive x lives right here, can you guys visualize where negative x lives? It's to the left of negative 4. Remember, every number and his opposite are a mirror image with each other, right? Where 0 is the mirror, so 7 mirrors negative 7. 12 mirrors negative 12. It's a mirror or a reflection. So wouldn't x then mirror negative x? Do you guys agree that it'd have to be the same distance away from 0, but just on the other side? So if this is negative x, take a look at the relationship between negative x and negative 4. Negative x is to the left of negative 4, and if you are to the left of something on a number line, you must be less than that value. But our original inequality said it's greater than. So whenever we do the whole mirror thing, that's why we have to flip it. Make sense? So when do we flip? Whenever we multiply or divide by a negative. Or if you just decide to write something in a different order. Like if you had an original question or original problem that said 2x plus 7 is greater than 24. Well, if you decided to rewrite that with the 24 on this side and the 2x plus 7 on this side, obviously the 24 is supposed to be the smaller one and the 2x plus 7 is supposed to be the greater one. So if you rewrite it, you'd have to flip it as well, right? I could never remember which one was greater than or less than, and I had a teacher one time, a long time ago, teach me what? You guys know what I'm going for here? The alligator's mouth. Anybody heard that one before? The alligator likes to eat the bigger number. Yeah, I mean, that's like a little kid thing, and I've been teaching math for 15 years, and I still think of it that way. Okay, so if you like to think of it that way, that's cool. Okay, here's what I'd like you to do. On Blackboard, underneath 2.7, we just went over that PowerPoint. You don't have to look at these two things if you don't want to. If you want a little video lecture of me going through a bunch of examples, there's a YouTube video that I made many years ago that you can watch later. It's like 20 minutes long. There's a website here. It's one of those math is fun. Remember when I made you guys do that snapshot, save it, and I gave you a grade on it from the completing the square? It's the same website except it's an inequalities website. So if you want to go to that website, look at some examples, there's a little practice test at the end. I'm not going to make you turn it in. It's purely for your practice. But what I'd like you to work on is these 2.7 checkpoint examples. Now, the solutions are right there. But for the next 20 to 25 minutes, I would say try to keep that document closed. Don't look at it until you're ready to look at it. Try to see if you can figure out some of these on your own. So I want you to open up this document. It says 2.7 examples. It's just going to say solve for x. And you can write these down on a separate piece of paper. If you wanted to click print on this and grab it off the printer, you're more than welcome to do that. You don't have to. What I'd like you to do is work on these. I think you'll find like number 3, number 4, not too bad. Number 6, A and B are a little bit different. See if you can figure out what the learning objective or make a conjecture about what's going on with 6 and 6B. Number 7 is what we call a compound inequality. So far we've had a left-hand side and a right-hand side, correct? And then either an equals or an unequals in between. Now we actually have 3 sides. We have a left, a right, and a middle. That's okay. We're just comparing 3 things instead of comparing 2 things. But you can still, whatever you do to the left, you do to the middle, you do to the right. So some of you may have seen that before, a compound inequality. And I would argue that your most challenging ones are going to be number 9 and number 10 because they involve absolute value. So those will take a little thinking, and maybe we'll have some time to talk about those at the end of the day. So go ahead, get to work. Try practicing these. If you have still questions about 2.6 or about your spreadsheet, you can ask me questions on that as well. Oren's going to be floating around helping out as well. It's,
You print them off.
I don't think we even, did I even print them off, or did I have them print their own?
No, we printed them off.
Okay, let me print one for him. Okay.
Please print it already.
Yeah. Let me find it first. What was it? 2.5. Should be coming out now. I was just telling Oren on the way up here today how as I get older, I struggle to learn people's names. So if you see me staring at you and staring at this sheet, it's because I'm trying to learn your name. I got some of you down. Ella, I think we were missing one thing from you because you weren't here the day we had.
And I have it done and everything.
Oh, perfect. Give it to Oren.
Okay.
Yep, Oren, you can grab Ella's there.
What? You can just... Thanks.
Listen here.
Actually, does that sound right?
Yeah, she's gone. AJ's gone.
Just write to her next time.
Yeah, I think that's
Okay, yeah.
right there. And then AJ. Otherwise, I think we got everybody. Yep.
I had a question on the 2.6 quiz. I got 100% on it.
Yeah, sure.
If I
Pull it up.
I don't. Okay.
Yep.
If I open it up, I won't lose the grade I got.
No.
Okay.
You no. Go to your grade center. Oh, you know what? I don't show you guys. Go to your grade center. I think you can view it from your grade center. Yep, click there. And, it doesn't show you the individuals. Okay, so go back in and open it up like you're going to redo it. You won't lose it.
Okay.
Yep, sorry, I thought it would show. Was it the year one?
No, that was the last quiz.
Yeah, so okay, because I talked about that one with somebody else yesterday. Go to view.
That just shows this again.
That just shows that again. Yeah, go like you're doing it again. And then you can exit out of it.
It was this first one.
202, 297.
Okay, so with this one,
Yep.
if I was to use, so I know the answer was 64.
Both plus and minus.
But if when I plugged the minus in, it gave me a negative 16.
Okay, so go back to that again. Okay, so you got x to the 2/3, right?
So it would be x to the 2/3 equals 16.
X to the 2/3 equals 16. Okay? So, what you're saying is the answer was 64? Right? So, if I plug in 64 to the 2/3, okay, there's two ways I can do this. I can either square it first and then later on take the cube root, or I could cube root it first and then later on square it. You see how both of these are going to give me 2/3? That makes sense?
Okay.
So 64 squared is a monster number, so I don't want to mess with that. I'm going to do it this way. I'm going to find out what the third root of 64 is, and then I'm going to square it. So what times what gives me 64? 4. So the answer inside here is 4, right? So I want 4 squared, which gives me 16. So it works, right?
Okay, I guess I was doing it. When I did this, I took the square of it, which would be 4 times 4.
Yep.
And then I cubed it.
But that would be
Negative.
then you cube rooted it. You mean?
Yeah.
Okay, so it'd be 64, but it's to the 2/3, not the 3/2. Oh yeah, I see. You're solving it there. Yep. So you're saying you took negative 64 and did what to it?
Oh, so I was supposed to take
Yeah, 'cause
and then square it.
yeah, because it's cube root of it and then square it, or you could do it the other way. You can square
the
it,
cube root of it, it would be a negative 4.
and negative 4 squared is positive 16. Okay. Yes. So the rule is, if this was our original equation, if this number, the numerator, if it is an even number,
You can have 2.
we are going to get 2 answers.
Okay.
Because it could be negative, we take it to an even power, turn it into a positive, or positive, turn it in, it's going to be the same. If it's, let's say it was this, okay?
Then you can't.
If it's an odd, then the only possibility is that it's got to be a positive, because we're only going to get one answer, because I can't end up with a negative and then square root it. That would be imaginary. So this, if it's an odd, we're going to get one answer. If it's an even, we're going to get 2 answers. Yep.
So I went backwards. I should have cubed it and then squared it instead of squaring it and then cubing it.
It doesn't matter what order you do it in. This is always
because if I square 2 negatives, it's going to be a positive.
correct. So if you have x to the 2/3, right, equals 16, that was the original problem.
Yep.
I can rewrite this as x squared to the 1/3. That's one way to rewrite it. I could also rewrite it as x to the 1/3 squared. That's another way to rewrite it. Either way, let's pretend it's negative. If it's negative and I square it, positive. If it's negative down here and I take the cubed root, it's still going to be negative. And if I take a negative and square it, positive. That's why negatives and positives both work. Yeah, I know it's a difficult concept. It just takes a little bit of practice. Mm-hmm.
Would I first want to
You certainly could. Yep. So take a look at what you have. I mean, you could subtract 3x from both sides if you wanted to. So what's going to happen if you do that? All your x's are going to go away. So try it once. So you're only going to be left with 1 is greater than 2. So is 1... Oh, wait. Did you write that down right? You didn't distribute it. That should be a 3. Right? 3x plus 3. So you end up with 3 is greater than 2. True or false? True. So if 3 is greater than 2, does it matter what x is? Because if you go back up and you look, x could be any number in the world. You triple it, over here you triple it, we're still the same, right? If I take any number in the world and I add 3 to it, and take that same number and add 2 to it, do you agree the left-hand side is going to be greater than the right-hand side all the time? So it doesn't matter what x is. So how do we write that? What's the answer for x? How do we write any number in the world? From where to where on a number line? What's the smallest number it could possibly be? What's the number on the far end of the left-hand side of a number line? Negative infinity, right? So from negative infinity all the way to positive infinity, that's the way we write all real numbers. Like every single number that you can think of would work. Does that make sense? Yep.
Oh yeah. How are the answers?
What quiz? It's multiple choice. So you're asking what format?
Yeah.
It'll be multiple choice, and you'll just have to see which ones are available to you.
Okay.
Yep. Blackboard's not smart enough to have the user enter interval notation or less than or equal to signs. It just doesn't work.
So that'd be -3 is less than x.
Did anybody finish both 6A and 6B? What somebody that understood what happened in 6A and 6B, can you tell me, give me a conjecture or give me like what the heck is going on with 6A and 6B?
First one's false, second one's true.
I think it was actually the first one was true and the second one was false. Is that what we got just now? Like when you did 6A, let's see what I got here. You should have found out that regardless of what happens, on 6A, whether you get rid of the 3x's or whether you just say, hey, 3x plus 3 is being compared to 3x plus 2, you could actually stop right there and say, if 3x and 3x are both there, one of them I'm adding 3 to and the other one I'm adding 2 to, wouldn't it make sense that the left-hand side is always going to be larger than the right-hand side? Because I'm adding 3 to one side and 2 to the other side? So it doesn't matter what the value of x is. I can pick out any number I want and plug it in for x. It's always going to work. Does that make sense? So what is my answer for that one? All real numbers. Every single number works. How do you write that in interval notation? From negative infinity all the way to positive infinity and every number in between. That's interval notation. But what happened on B? There is no solution because how in the world could x plus 1 be less than x minus 1? That's impossible, right? If you have x and they're the same, and you add 1 to one side, and you subtract 1 from the other side, there's no way the one on the right could possibly be greater than the one on the left. It's impossible. It's just a little bit of common sense intuition, right? So if it's impossible, what values of x would work? None. There are no solutions. One of the ways that you'll see that, if you look at the way I wrote that down, this is what we call the empty set. It's a 0 with a slash through it. There are no answers. Honestly, I don't even think you can write that in interval notation because there is no interval, right? There's no interval of answers that would work. So you either write no solution or this little sign meaning the empty set. The set of solutions is empty. Okay, I'll let you get back to work.
So once we figure out that like x is greater than or equal to -1 or 4 is greater than x, when you have to write that interval with notation, it's like an answer.
You could write it either way. So
Either way, so
you wrote it as 2 minus 3x. I think you should have said, yeah. So that's the way I wrote it. X is greater than or equal to -1.
Yeah.
That's perfectly acceptable. The other way to write it would be in interval notation where x goes from -1 all the way to infinity. These two things say the exact same thing. Those two things say the exact same thing.
Okay, so I don't have to worry about maybe putting this instead of that, or
Yeah, one is no more right than the other, but if I were to give it to you in multiple choice, and you only understand one of them, and you don't recognize the other one, you might get in trouble. So you should be able to visualize both. But right, I'm not going to make you use one notation over the other.
okay.
Yep.
Thank you.
Was it actually?
Yeah.
What's up?
It's not a question about this.
Yeah.
Since I'm going to miss the exam on Friday,
Oh yeah.
when
Okay.
do you want me to take it?
You can take it whenever you want. What I'll have you do, you could theoretically take it before Friday if you want, but you can just take it next week if that's more comfortable for
That
you.
definitely will be.
Okay. So what I'd have you do is contact Jackie Owen at the Learning Center. She proctors tests all the time. That's where some of my online students take it. All you got to do is say, I need to set up an appointment to take my Math 103 test. I have the test is protected by a password. So you can't get into it without the password. She has the password. So you just got to set up an appointment with her and good to go.
I've never missed an exam in 3 years of being here.
Hey, no problem. No problem. It happens. If and when you have an answer to number 9 or 10, I'd like to come look at it. And maybe you've already checked the solutions manual, but I'd like to see how you did it. Actually, even 8, 9, or 10. How'd you do?
I don't know.
So number 8, you're saying from, I think it's -3, not +3. I got -3. So you did x minus 2 is less than 5. So x minus 2 is, oh, wait a second. What did you,
I don't know. What did I do?
this is correct. X minus 2 is less than 5. So x is less than 7. But I'm not sure why you have an x plus 2.
Both sides.
Yep, but you put the negative in the wrong spot. So you have x minus 2 is less than 5, right?
Yeah.
Here, I'll show it to you on my paper here.
No, you're just going around.
Well, this is why they're tricky. You got to stop and think for a second. So if x minus 2 is less than 5, I like to draw a picture. Okay, here's 5, here's -5. I know that x minus 2 cannot go past 5. It can't be over here. And it also can't be over here. Because if it did, the distance away from 0 would not be less than 5 anymore. It would be more than 5, and that's not what we want. So I see two scenarios. I see that x minus 2 definitely has to be greater than that number. So x minus 2 has to be greater than that number, and it also has to be less than that number. So you got the less than part right. You're saying x minus 2 has to be smaller than 5. Mm-hmm. Correct. But over here, it's not x plus 2. It's still x minus 2. But we want to make sure x minus 2 is to the right of -5.
Yeah,
That's where it can really get confusing. So let me just check your.
The rest of them might be wrong with.
Yeah. So when you worked it down here, okay, careful here. Here's another mistake. When you take -3 times the absolute value of something, this absolute value bar is not a parentheses. We cannot distribute.
Oh.
That's a whole different thing. It's not legal, if you will. So what you want to do is get rid of the -3 by dividing or doing whatever. Try to isolate that absolute value expression, and then set up your little scenario where it has to be, whatever, greater than or less than the two numbers on my number line.
Okay.
I've seen a couple of you do this over the last few days. Keep in mind, like on number 9, for example. Here's number 9. Negative 3 times the absolute value of 5x minus 2, that is not the same as negative 3 times parentheses 5x minus 2. Those are different, right? If I have negative 3 times this, I can distribute. Like those two things are the same thing. But when I'm taking an absolute value, that does not allow me to distribute. That would be bad. Okay? An absolute value bar is not equivalent to a parentheses, so don't fall into that trap. So what would you do with that guy? What we want to do is we want to isolate my absolute value. I want to get rid of every single thing that I can so that I only have absolute value of 5x minus 2 left over. How do I get rid of the 20? Subtract it from both sides, right? How do I get rid of the negative 3? Divide both sides by negative 3. And of course, if I divide by a negative, what am I going to do? Flip the sign. Yeah. So if I go through that process on number 9, if I do those two things, on number 9, notice I subtracted the 20. So if I go minus 20, that's how I got the negative 39 now. And if I divide by negative 3 and divide by negative 3, now notice my absolute value is isolated. It's the only thing left on that side of the inequality. Negative 39 divided by negative 3 is 13, and notice my sign flip. I went from greater than or equal to less than or equal to. Now I'm ready to solve. That 20 and that negative 3, they were just a nuisance. They were just in the way. Now I'm ready to apply my whole absolute value thing, right? This is where a lot of students are going to get tripped up. Okay? You need to understand what these bars mean. And what do I always say? Absolute value is the distance away from 0. So we're saying the distance away from 0 has to be less than or equal to 13. Think about 0 as being like your home. And you can only travel 13 miles away, and that's like your barrier. You can't go any further than that. Okay? So what I'm saying is 5x minus 2 cannot travel any more than 13 units away from 0. It has to be less than 13. So negative 13 would be a barrier. I cannot go past him. Now I can go right onto him because it's less than or equal to. That's why I'm using a bracket, right? And I also cannot go past positive 13. Okay? So I cannot be over here, and I cannot be over here. So if you can visualize that, what do you know about 5x minus 2? You know that it needs to be to the right of negative 13. You also need to know that it needs to be to the left of positive 13. So I set up two scenarios. This one says 5x minus 2 needs to be to the right of, greater than or equal to, negative 13. And it also needs to be to the left of positive 13. Now I go through and I solve it, and I find out that x needs to be greater than that number, and it needs to be less than that number. Well, greater than that number means I can start at that number and I can travel to the right, and I can travel to the right on my number line all the way until I get to that number. There's a lot going on in that problem. And again, I'll cite kind of my thinking process. I'm not saying you have to think like me, but when I see that, this picture helps me tremendously, so I don't end up screwing it up. And like I said, I've been teaching math for 15 years, and I still draw the picture because it helps me visualize it. So if drawing a little sketch of a picture like that helps, then I encourage you to do so. Really quick on number 10. when you end up doing that one, notice that you end up finding out that your distance away from 0 doesn't need to be less than a certain amount. It needs to actually be greater than. See how this is different? So it needs to be greater than 18, meaning this time you must go at least 18 units away or 18 units on the left. You cannot be within 18. See how that's opposite? So you'll get a practice on both of those. Really quickly about the test. So the test has 20 items on it. Some of them are going to be the kind of item that you can read it and you should be able to come up with an answer in literally 2 seconds. It's that easy if you understand what you're doing. Others of them are going to take you 5-6 minutes to work through some things and try it. In my experience, almost every single person finishes in under 50 minutes, but I'm not going to kick you out. When it's 1:50, I'll give you time to finish. If you don't finish, it's just that we're probably going to have to move to a different room because there's class in here. But I'll have that arranged for you guys on Friday. If you need more time, I'll have that arranged. So there's 20 items. You can use whatever resources you want, except for your neighbor. Okay? So you can use your GeoGebra. You can graph something. You can use your Excel spreadsheet that you've been building. You can use all of your notes, all of your homework. Any document or PowerPoint that I've put on Blackboard, that is all fair game. Your textbook, you can use any of it. Okay? Your calculator, you can use that too. So you should be organized with your notes and your practice homework and the worksheets that you've been working on and stuff like that, because the more organized you are, it's probably going to be that much easier for you to get through the test. And the test is worth 50 points. That's not a lot. Okay? For example, the worksheet we just handed back to you is worth 18. And the spreadsheet I have you working on, that's worth 20. So just those two combined are 38 points. That's almost the same as the test. So don't think that this test is gonna, like, if you get a terrible grade that you're finished, and don't think that if you ace it, you've somehow aced the class. It's worth 50 points. I think the tests, by the time we're all said and done, I'd have to look at the syllabus again, I think it adds up to about 1/3 of your grade. So we do a lot of other things in here where your grade adds up other than just taking tests. So the test isn't the end-all, be-all of everything. Anybody got any questions before we break? Okay. See you on Friday.
You really done it there.